Hi, Aggie's physics class.
In order to calculate velocity, I use the projectile motion equation that calculates velocity in terms of the x value. There's no acceleration in the x, and the starting x is 0, so from there you can calculate velocity. In order to calculate force, I use the equation that the change in momentum over the change in time equals force, with the starting velocity being 0 and the ending velocity being the velocity I calculated. I can therefore calculate force. In order to calculate work, I use the equation that work equals the change in kinetic energy. Since the starting velocity is 0, so is the starting kinetic energy is also 0, and that makes work equal to kinetic energy at the end. In order to calculate power, I use the equation work over T equals power. That was an easy calculation to place the work number over the amount of time that it took for that for that work to be done, and I calculated power. Here, I performed all of these calculations for each of the following hits. Here are my data and my results. This is the data that I collected. If you look in the packet in front of you, it's the first 3 columns. After collecting this data, I used Excel to calculate velocity, force, work, and power. Here are the conclusions that I can make from this data. I originally hypothesized that the harder that you hit the ball, the farther that it will go. But Emily had the hardest hit, and she imparted the most force to the ball, but Joyce had the longest hit. The hit that Joyce had that went the longest was at the most ideal angle, 31.8 degrees, with the ideal angle being 30 degrees. So distance of the hit must correlate more with the angle of the hit than how hard you hit the ball. So hitting the ball at a 30-degree angle is more important than crushing it. This, therefore, disproves my hypothesis and shows that it is the angle, not force, that affects the distance the ball travels.
Thank you, physics class.